So that first ELO in Unit G. So the key thing, again, is we're shooting for a 3. I can simplify expressions involving positive and negative integer exponents. So today we're going to start talking about the negative ones. We're going to talk about what those exponents mean. As you're looking at that, you're going to be able to simplify positive exponents. You're going to make sure, if you read this one, anything to the 0 power is 1. What is anything to the 0 power? 1. What is anything to the 0 power?
1.
Anything to the 0 power?
1.
4 to the 0?
1.
7 to the 0?
1.
X to the 0?
1.
So anything to the 0 is 1. You got to get that in your brain. Anything to the 0 is 1. So we're going to talk about those. You're going to be looking at vocabulary, exponent, power, base. We're going to do that today. The second half of the unit is with scientific notation. So it's using decimal and scientific notation, so being able to do that. And then this last part, not an ELO, but looking at performing operations, adding, multiplying, dividing with integer operations. So if you look on page 2, please, of your notes. On page 2, it says in this unit we're going to be learning about exponent scientific notation. Today we're going to start. And the question is, what are exponents and what are they used? Are used because they're a way of showing us how many times we're going to multiply. So I like that. This is telling us how many 3 should I have? 2. I should have 3 times 3. So the exponent tells me how many times I put that base. So 3 times 3 is 9, right? 3 to the second, going back to the beginning of the year when you had to memorize all those squares and cubes, right? 3 to the 4th does not mean 3 times 4. Remember, it tells me that I have to have 4 3s. And if you think about that, the first 2 3s are 9 times 9. 3 to the 4th is, 9 times 9 is 81. So what does the exponents, what are they used for? They're a shortcut for showing multiplication, right? Exponents are a shortcut because they tell us how many times we are multiplying when we take a look at it. So as you look at that next part in your notes, it says, as we look at this whole thing down here, so 8 to the 3rd, it says the exponent is the 3, the base is 8, and the power is this whole thing that's circled. So when we take a look at that, it says, if we are looking at, what I want you to put down in that first blank is a power. So please write in the word power, is a way of representing repeated multiplication. If I'm looking at that next one, the number that is repeatedly multiplied, that is our 8 in this case, or our base. And the number of times that it's being multiplied by itself, that is called our exponent, as we are looking at those. So please fill in those 3 words as you are taking a look at that. Using the definition of exponents, we want to write these out in what's called expanded form. Now, expanded form just means we want to show how many 5. So 5 to the 6th means that if we are looking at that, I should have how many 5s? I should have 6 5s. So please write 6 5s down. So I have 6. And then Jarrett, times 5 to the 2nd means I should need 2 more 5s. So if I was looking at this, we definitely don't want to put this in our calculator. It's pretty big. But Morgan, if I was looking at that, how many 5s do I end up having? 8. So my power for this one is I could write this as 5 to the 8. Okay. If I'm looking at this next one, Jonathan, x to the 3rd means how many x's? 3. So I'm going to have x times x times x. Right? Autumn, x to the 7th means how many more? 7. 7 more. So I want to make sure I put 7 more. And if it helps you to put the little dot in between, but we're always being multiplied when we are writing those. So if I'm looking at my total number of x's as I take a look at that, Tyler, what would you say? 10. So we are going to be looking at a pattern. And so as you look at this, I just want you to tell your shoulder partner, what do you think the pattern is to get 5 to the 6th times 5 to the 2nd to get 5 to the 8th, x to the 3rd, x to the 7th to get x to the 10th? talk to your shoulder partner right now and see if you can come up with that. That when you multiply the same base, what did you do with those exponents? You added them, right? So when you multiply with the same base, so when you multiply powers, if they have the same base, please make sure you're writing this down. It has to be exactly the same base. They are both x's, they are both 5's. We are going to add those exponents. That's a nice shortcut, right? We do not want to write out always 7x's and 3x's. We don't want to do that. That takes too much space, too much time. So we want to use that rule as we are taking a look at these problems down here. So that we are going to be adding our exponents. Now, I do not need you to put this down when you show your work. I think most of you can add 8 and 3 and tell me that you are going to have b to the 11. But sometimes in your notes, it's helpful to make sure you put this because I'll have some people tell me 24 because they want to multiply the 8 and the 3 because they're multiplying the base. Nope, you add the exponents. So if I'm looking at that next one, Grady, I'm going to have 7 and I'm taking 14 plus 6. I'm going to get 7 to the 20. We're not going to put these in our calculator. We're going to leave them like this. Okay. This next one, is the base the same, Amy? No, the base isn't the same. So our answer is going to be a to the 5th and c to the 5th. You can't add those. They are not the same base, right? So not the same base, you can't add. Right? They have to keep it exactly the same. When I look at this last one, Liv, I have 10 to the 4th, and there's a 10, but there's no exponent. What number is understood to be there if it's not written in? A 1. So now I can think of this and go, oh, 4 plus 1, which Liv gives me 10 to the 5th. Okay? Questions? What it tells us to do is looking for another pattern. Using our definition of exponents, we want to write this out. So 2 to the 5th. If I am writing that out, mark how many 2's should I have up on top? 5. Please put, not 2 times 5. I need 5 2's. So please put 5 2's in your numerator. In our denominator, Kaizen, I need how many 2's? 3 2's. And if I'm looking at this, Cameron, 2 divided by 2 is what? 1. So this simplifies to 1. Another 2 over 2 simplifies to 1. Another 2 over 2 simplifies to 1. And my answer is 2 to the 2nd. And I want you to be thinking like the last one. When we multiplied, we added those exponents. When we're dividing, try and think about what pattern, okay? If I look at k to the 6th, okay? Cameron, k to the 6th means how many k's? How many? 6. So please write down 6 k's are being multiplied together, right? In our denominator, if I'm looking at it, Alea, k to the 2nd means 2 k's. If I'm looking at that, I have k over k, which is the same as 1. I have another k over k, which is the same as 1. And my answer is going to be k to the 4th. So thinking about your numbers 6 and 2 to get 4, 5 and 3 to get the 2. If we are looking for a shortcut, anyone want to give it a shot, what they think the shortcut is, Alexander?
The ones that are left, you make that the...
So when we divide, when I divide, what do you think you have? Go.
You take the 6 minus the 2.
The 6 minus 2. Does that work if I take 5 minus 3? Mm-hmm. So the shortcut for our pattern would be, please write this down. When dividing with the same base, we are going to subtract our exponents. So if you think about the problem that was here, if I would have taken 5 minus 3, right, I get 2. If I would have taken 6 minus 2, I get k to the 4th, right? So when we multiply, we add our exponents. That's the same base. Has to be the same base. And when we divide, we are going to be subtracting. So, parentheses are super important. If the problem starts with a parenthesis, your answer must have that parenthesis in it. So, we are going to put -8, and we are going to put that to the, we're thinking of subtracting, 5 minus 3, which really gives us -8 in a parenthesis to the second. And I always have students say, why does it matter if it's in a parenthesis or not? So, if you have your calculator, I want you to, and actually you don't even need your calculator for this one. What does this mean? How many -8 am I multiplying? 2 of them. And if I have -8 times -8, that's equal to a positive 64. Here's the difference. If I have this without a parenthesis, and I still have students in algebra, and I know as they go on, they still get mixed up with this. This is a different answer. This one means -1 times 8 to the second. Here, I took -8 times -8, got positive 64. What's going to happen here? I'm going to take -1 times 64. My answer is going to be -64. You have to know the difference. If you put it in your calculator without a parenthesis, your calculator thinks you want this answer. If the problem is written like this, you should be getting this answer. Your calculator does what you tell it. You don't put the parentheses in. It thinks powers first, then multiply by -1. It's following the rules of multiplication, like the PEMDAS, right? It's taking the exponents first as you look at that. Now, in this one, does it matter as much? No, because we don't have anything in a parenthesis. And again, we're taking 11 minus 9. So if I am looking at this, I'm going to have m to the second. This one, keeping your answer as a -8 to the second, as we are looking at them. Questions? The homework does, we're going to write them out in expanded form. We're going to rearrange, right? So first we write out what it looks like. So they started with the 3, they put 2 x's, then they put the 4, then they put 3 more x's. When they rearranged it, they always put the 2 numbers together, right? So we're going to put our 2 numbers together, and then you have all those x's, and then we're going to multiply these 2 together. Because a simplified form means we don't want to have things being multiplied. We want the least amount of things written down. So we're going to start with the next one, and I'm going to put -2. And then I'm going to have, if I'm looking at that Embry, what? Nope.
No.
Right behind the -2 was what?
-2.
How many x's?
2.
2 x's. Okay, we're going to let you keep going. Then I have a what?
5.
5. And then how many more x's?
4.
4. Nice. When I go to rearrange, we're going to put our 2 numbers first, which means I'm putting the -2 times the 5. Then I'm going to put my 2 x's and my 4 x's. So I should have 6 of them now. We are going to be starting to multiply. Kale, as I'm multiplying the numbers together, I'm going to end up with what? The 2 and the 5 when I multiply. -10. And Brad, I'm going to have x to the what power? X to the what? 6. 6 or 5? Does that make sense? Because I had 2 and 4 that we're adding. I have 2 x's, I have 4 x's, 2 x's, 4, I have a total of 6 of them. Okay? All right, so we're going to start this one out. Max, now that's how many xy's do I want? What's our x? 3 of them. I'm going to put xy times xy times xy. Or do you have something to write with?
Yeah.
Okay. I am then going to rearrange and put all my x's. So I'm going to have the 3 x's first, then I'm going to have the 3 y's. I'm writing that solution as I am taking a look at that. When I look at that solution, Ivy, I'm going to have x to what power? 3 and y to the 3rd as I'm looking at that. Carson, how many 4 x's do I need to write down in that next one? 2. I'm going to put 4x times 4x. I'm gonna rewrite that as 4 times 4, putting my numbers and then grouping my like terms, which are my two x's. 4 times 4, if I'm multiplying that, Ben gives me 16, and then I'm gonna have x squared. I want you to try these next ones. Try them on your own, just the first column. Do the first column on your own. So think of what is that going to look like for the first column, okay? And I'm going to give you arranging if I was looking at the last two. I'm going to put x over y. I might write this expanded form, but I think we can go right to the answers for these two, right? How many x's did I have on top? X to the 4th over 5 to the 4th. In the last one, I had x to the 3rd, and in my denominator, I have 3 y's. Y to the 3rd. Now, the only thing that sometimes happens with students is that it's really hard to see their exponents, and I'll show you what that looks like in just a minute. So if I go back to this one, I need to rearrange it with -3 times -3 times -3. Then I'm going to have my 3 x's. When I start multiplying, -3 times -3, that leaves me with 9. 9 times -3 leaves me with a -27, correct? -3 to the 3rd, -27, and then I'm going to have x to the 3rd. Now what I was talking about is that sometimes, some of you, your writing is really, it looks like this, like x3. Now there were some of you on the last test, when you tried to tell me something was like 4a, you don't like writing the number in front, so this almost looks like it could be this. And it's not supposed to be. It's supposed to be x with an, so try to make either your base bigger so that you can make, however you need to do that. But if it looks like this, like that really doesn't look too much like an exponent, right? So those of you that are a little sloppier in your writing, a little careless, just be really careful for that, okay? Your homework that you are working on, it is not very long. If you would please turn back to page 38.